Hi, I'm Mary. This is another magical math moment. This video is going to be looking at the quadratic parent function as well as some function properties. So let's get to it. We're looking at the function f of x is x squared. This shape is a parabola, and when you try to describe it, it's a U-shaped graph. So we're going to plug in some of these x values here to see what happens. If I put -2 in for x, -2 squared is essentially -2 times -2, which is +4. When I put -1 in here, I get +1. 0 squared is also 0. 1 squared, 1. 2 squared, 4. You're probably seeing a little pattern in what's going on here. So we've got -2, 4 up here, -1, 1 here, 0, 0 here, 1, 1, and 2, 4. So when you graph this, you want to try to have a little bit of a curve down here. I'm not using a grid, so it's not perfect, but you get the idea. Now, something that's cool I want to point out for you is that from this minimal point, which is called the vertex, you can see a pattern that kind of comes out here. So if I look from the vertex, I'm going up 1 over 1 in both directions. Okay, up 1 over 1. From the next point, I'm going to go over, sorry, I should say I'm going up 3 over 1. Up 3 over 1. Now, if you had to take a guess at what was going to happen next, we would be going up 5 over 1. Math is patterns. So if you could figure out what the pattern is, you've got half the battle fought for you already. So you can see this is 1, 3, 5. These are ascending odd numbers. That means they're getting larger over time. So 1, 3, 5, 7, 9, etc. All right, so this pattern will continue on. Now, when you start transforming them, that's where things change a little, but we're not dealing with that in this video. We're just looking at the parent function. Let's take a look at the domain range, increasing, decreasing intervals, positive, negative intervals, and extrema. Okay, here we go. Domain are your x values. They go left to right. So as I'm looking to the left, this is defined from -infinity to infinity. So I can write that as an inequality. I can say -infinity to infinity like that. I can also get very creative and say all real numbers, which is this goofy looking symbol. It's one of my favorites. I learned that in college. Okay, range are your y values. So again, they start at -infinity and go up to positive. Now this function isn't defined down here. It starts at 0. So all of our y or f of x values have got to be greater than or equal to 0. So f of x is greater than or equal to 0. If you wanted to write this as an interval, since 0 is included in the range, we would put a bracket, and then it goes up to infinity. All right, let's see what else is happening. Increasing is when the function goes up, so we can see that that's happening on the right side. So from the x value 0 to infinity, it's increasing. 0 less than x, less than infinity, or interval notation, 0 to infinity. Decreasing is where the function is going down when you look at it left to right. That starts at -infinity and stops at 0. So -infinity is less than x, less than 0, or interval notation, -infinity to 0. For those of you going on to higher level maths, they're going to really want you to be using interval notation. Inequality is fine too, but most of the time you're going to be dealing with this. All right, another thing to talk about are the positive and negative intervals. If we look at this, all of the y values are positive except when x is 0. So there's a couple of ways that you can write your answer for this. You can do it as 2 intervals. So you can say -infinity less than x less than 0 and 0 less than x less than infinity. Another way that you could say this would be all real numbers, x not equal to 0. And that's the way I tend to like it. Or all reals with a comma, x not equal to 0. You could also write it as an interval, and I'm kind of running out of space for this, but the interval would go from -infinity to 0. We'll put a u in here for union, and then 0 to infinity. So that means we're not including the 0 with this. All right, negative, there is no negative. Everything's positive here, or 0, so none. The extrema, that's a fancy term for maximum or minimum. When I look at this, I have a low point, so that is a minimum. Since it is the absolute lowest minimum on this function, I'm going to say that there is an absolute minimum at 0. Now it's important to remember that the 0 is the y value. If they want to know the coordinate pairs where it's happening, you would say 0, 0. If they want the value of the minimum, you're going to say it's an absolute minimum, a value of 0. Okay? I hope this has been helpful for you. Share with a classmate, and I'll see you next time. Bye.